humans, I'm Mr. Khing. Hey, what's up? Welcome back. So now we are going to this past year paper, May-June 2021 paper 43. Alright, okay, let's go. CQ1, okay, name the process, okay, for the following, see first, okay, to produce large molecule from monomers, okay, from monomers to polymers, it is called polymerisation. To separate oxygen from liquid air, fractional distillation, okay, based on different boiling point. Then ethanol from glucose, fermentation. Okay, to separate water from the aqueous solution, it has to be simple distillation. Okay, remember this. Whenever you see questions asking you to separate water from the solution, 100% it is always simple distillation. Alright, okay, then aluminium from aluminium oxide dissolved in molten chloride, okay, is electrolysis. Separations of products of the hydrolysis, okay, of carbohydrates, okay, it is chromatography. Remember, chromatography is used to separate all the natural monomers, okay, like example like glucose, amino acid. Okay, then aqueous solution from undissolved solid. Liquid from solid is filtration. Okay, then next one. Okay, proton, electrons, neutron. Okay, remember, you see the number, okay, for the element symbol, okay, the numbers on the top left hand corner, it is always the sum of p plus n, so called neutron number. Okay, bottom left hand corner is always just proton itself. Yeah, so it's given here, so we know that proton is 5, neutron is 11 minus 5, get 6. Okay, then you see given with this chloride ions, you see the charge is -1. Okay, so therefore it has 1 extra electrons compared to proton, so 18 electrons. Neutron 35 minus 17, you get 18. Okay, then next one. So how do you know what's the elements? Yeah, you have to look at the proton number. You see proton number 24. So if you refer back to the periodic table, okay, the elements with 24 proton, it is chromium Cr. Then proton number 24, neutron number P plus N, 24 plus 30, you get 54. But then you see, if you check on the proton electrons, you see 3 extra protons compared to electrons. So therefore the charge is 3 positive. Then chemical equation, so you see sodium reacts with fluorine to form sodium fluoride. Okay, you have to make sure that the equation is a balanced equation. See, left hand side 2F, right hand side have to make sure they are 2. So eventually, so this is how you balance the equation. Okay, then how do you draw this? You see dot and cross diagrams. Okay, see sodium, we know that sodium, it has 11, so it donates 1 to form 2, 8. Okay, fluoride, initially it is 2, 7, so it gains 1 to form 2, 8. Alright, so you see dot and cross. You see, initially you see fluoride, it has 7 valence, so therefore there will be 7 dot and 1 cross. Okay, to show that it gains 1 electrons from sodium. Yeah, and then followed by indicating the charge. Okay, then define the term electrolysis. Okay, it means the breaking of ionic compound in molten or aqueous state using electricity. Okay, then products. So how do you know what are the products? So you see, when it comes into electrolysis, the very first thing you have to do is list out all the ions present in the electrolyte. See, this is aqueous sodium fluoride. So there are sodium fluoride, aqueous solution, hydrogen hydroxide. Okay, all the positive ions goes to cathode, negative ions goes to anode. So you see, this is dilute. Okay, always pick the one that's lower in the reactivity series. So which one gets selected at cathode? Hydrogen is lower. Anode, which one is lower? Hydroxide. Okay, but then you see, you're asked to name the products. Okay, not the half equation. See, when hydroxide gets selected to be the charge, the main products produced is oxygen gas. Cathode, hydrogen gets selected to form hydrogen gas. Okay, then you see this is molten. Remember, okay, molten means there's no H2O. So what are the ions present in the electrolyte? So sodium and fluoride. That's it. Yeah, that's it. So anode attract negative, fluoride get discharged to form fluorine. See, you're asked to name the product. See, F2 it produced. Okay, do not write fluoride. Answer, it has to be fluorine. Okay, because it is F2. Okay, and then sodium. Okay, and then followed by half equation. Okay, cathode. See, sodium ions gains electrons to form sodium atoms. Okay, then the drawings of this covalent compound. Okay, see, we know that F27. See, it needs one more electron, so therefore it can only share one. So which eventually, see, it looks something like this. You see, share one, see 7 valence, you share one, how many more electrons left unshared? 6, isn't it? So the remaining 6 electrons, okay, they remain outside. Okay, and then next one. Okay, deduce the physical state at -195. Okay, so you see, -195 is placed in between the melting point and boiling point. So from here we know that the state is liquid. Okay, explain. Okay, then you have to mention, okay, why is it liquid? Okay, because at -195 degrees Celsius, okay, it is in between the melting point and boiling point. That's it. Alright, okay, then okay, in terms of the structures and bonding, okay, why sodium fluoride has a much higher melting point than fluorine? Why? You see, can you notice, you see the difference between sodium fluoride and fluorine? Sodium chloride is an example of ionic compound. Fluorine is an example of covalent. Okay, and then in your answer, okay, you have to mention, okay, the types of particles, okay, the types of forces of attractions, yeah, and also the relative strength of the force. Okay, so first you have to mention, okay, sodium chloride, it has ionic bond. Okay, so what's the strength? Remember, ionic bond, okay, means that it has strong electrostatic forces of attraction between what types of particles in ionic compound? Ionic compound, they are made of ions. So the forces of attraction, it is the forces between oppositely charged ions. That's it. Alright. Yeah, of course, you can also talk about fluorine. Okay, if you talk about fluorine, then you have to mention, okay, fluorine has a covalent bond. Okay, it has weak intermolecular forces of attraction between molecules. Alright, either one will do as long as you compare. Alright, okay, then how to define the term equilibriums? Okay, remember, okay, the marks allocated for the definitions of equilibriums, it is always a 2 marks questions. And in order to get full marks, okay, these are the 2 definitions that you have to include. Okay, so first you have to talk about the rate of forward reaction and rate of backward reaction, okay, and they are both the same. And then next you talk about the concentrations of the reactants and products, and they remains unchanged or remains the same. Then see why the positions of equilibriums does not change. Why? Let me see. So in this case, isn't it, okay? You have to look at the numbers of moles on both left hand side, right hand side. Okay, I see when the plungers of gas stream is pushed in, okay, it increases pressure. But when the pressure increases, you see, the position remains the same. Why? Remember, you see, pressure affects the position based on the numbers of moles on both left hand side, right hand side. See, left hand side, how many moles? 2. Right hand side, 1 plus 1, you get 2. Okay, so this is the reason why the position does not change. Okay, both sides have the same numbers of moles. Or you can also say they have the same numbers of molecules, okay, at both sides. Okay, they are both the same. Okay, then why the color of the mixtures turns darker purple in color even though the equilibriums does not change? Why? Okay, because the iodine particle gets closer together. So keywords you have to mention, okay, iodine particles. Do not just write iodine. Okay, because iodine, they are molecules, isn't it? In the forms of molecules, you have to mention, okay, iodine particles or iodine molecules. Either one will do. Okay, they get closer together. So this is the reason why it turns darker purple in color. See, imagine, isn't it? See, initially, like example, okay, there are total 5 iodine molecule, like example, okay. You see, in this given space, you see, so this is the arrangements of the distance between the iodine molecules. So you see, imagine, okay, when the plunger is pushed in, yeah, so you see now all the particles, you see, they are now, they are now a lot more closer to one another, isn't it? The purple molecule. So this is the reason why it turns darker purple in color. Okay, even though there is no change on the positions of equilibriums. Alright, okay, then see, it's mentioned here. Forward reaction is endothermic, means backward is exothermic. So what happens to the position, okay, when the temperature decreases? Remember, okay, decrease in temperature will always favors exothermic reaction. So which one is exothermic? See, exothermic is the backward reaction, isn't it? So that's the reason why the position shift to the left. Okay. Okay, then, so what happens to the rate of both the forward and backward reaction when the temperature decreases? You see, they are asking about the rate of reaction, okay, not the positions of equilibriums. Okay, remember, decrease in temperature will always decrease the rate of reaction. So that's the reason why, okay, both the rates of forward, backward reaction can decrease. Okay. Alright, okay, next. Okay, see, it's about the preparations of salt. Okay, soluble salt, okay, from solid zinc carbonate and sulfuric acid. So see, your answer, you have to include the practical details, okay, how to make sure that all the acid has reacted and also followed by a chemical equation. Alright, so first you have to mention, okay, you have to add excess solid into the acid until there is no more reaction. But how do you know when there's no more reaction? Okay, see, metal carbonate reacts with acid. We know that it produces what? Carbon dioxide gas, isn't it? So when carbon dioxide gas is produced, so what is the observation? Gas bubbles. Okay, so which means when there is reaction, it produces gas bubbles. When there is no reaction, there will be no bubbles. So which means, okay, you have to add the excess solid until there is no more effervescence or there is no more bubbles formed. Okay, and then we have to filter to remove all the excess solid. And then followed by heating the filtrate until crystallization point. Okay, you have to mention you heat until crystallization point. Okay, then leave the solution to cool and evaporate. So when the solution undergoes evaporation, okay, we know that it forms crystals. So how can you obtain the crystal? Okay, filter out the crystal produced. Okay, and remember this, every time, okay, every single time after filtration, it is always followed by these two standard steps. Okay, you have to rinse the crystal with distilled water and then followed by drying with filter paper, and this is how you obtain a pure and dry crystals. Alright, okay, then followed by the chemical equation. Okay, this is zinc carbonate reacts with acid to form salt, water, and carbon dioxide gas. Okay, same thing, you have to make sure that it is a balanced chemical equation. Okay, then what is the test for sulfur dioxide again? Remember, sulfur dioxide is an example of reducing agent. Okay, and we test reducing agent with oxidizing agent. Like example, acidified potassium manganate 7. Color changes from purple to colorless. Okay, remember, you have to include the word acidify. Okay, do not just write potassium manganate 7. Okay, then how to balance this equation? Okay, how? Okay, you see, left hand side there, how many Fe? 2 Fe, isn't it? See, there's only 1 over here. So to make it 2, that's why we put 2 over here. See, after you put 2, now left hand side there are total how many hydrogen? See, 7 multiplied with 2, you get 14. Okay, but remember, you can see there's 2 in front, so which means everything you have to multiply with 2 again. So 7 multiplied with 2, you get 14. 14 multiplied with 2, you get 28. Okay, now you have to make sure that right hand side there are also 28 hydrogen. So how? See, there are 2 over here. To make it 28, we need 14. Alright, okay, so this is how balance this equation. Okay, then, okay, when we do this, okay, how can you make sure that all the water is given off? Okay, you have to, okay, repeat the heating and weighing process until a constant mass is obtained. Yeah, because you see, as long as the mass is still decreasing, means that it's still water in the compound. So when the mass stops decreasing, okay, means there is no more water in the compound. Alright, okay, the next one, you see, mole calculations. So numbers of moles of barium chloride. So first, what is the information you have about barium chloride? 4.16 grams, isn't it? See, you are given with mass. So the formula to be used is always mass over relative molecular mass. So you see 4.6 divided by, given here, 208. Yeah, so you press on calculator, you get 0.02 mole. Then what is the mass of H2O given off? Okay, see. Here you are given with the initial mass of the hydrated compound, and then you are given with the mass of BaCl2. So how do you look for the mass of H2O? Yeah, you get 4.88 grams minus 4.16 grams. Okay, you get 0.72. And then followed by the moles of H2O. So you see, what is the mass of what is the mass of H2O that you have? 0.72, isn't it? So you see, you are given with mass. So formula M over MR. So 0.72 divided by the mass of H2O is given here 18. Yeah, so you get 0.04. And after that, look for X. Yeah, you compare the ratio, you see. Given here already, yeah, you just compare the ratio. Okay, this is given 1 over here, 1 to X. Okay, so eventually you will get 0.04. Alright, okay, then, okay, furnace. Okay, name another substance that is added at the tops of the blast furnace. You see, other than coke and iron ore, what else? It is limestone. Yeah, remember you see limestone, coke, and air are the raw materials that are added into the furnace. Okay, then the substance that leave the blast furnace at A. See, A is over here. It is below slag. Remember, you see which one will always stay below the slag? It is molten iron. Okay, molten iron that have a greater density. And then name a substance that reduce iron shear oxide. Okay, remember it is carbon monoxide. Right? Okay, then what are the two substances that react together to produce high temperature? Remember, see, it is always the reaction between carbon and oxygen. Remember, C plus O2 to form CO2. This is the reactions that produces heat. Okay, then two waste gases. Remember, you see reductions of hematite with carbon monoxide produces carbon dioxide gas. So carbon dioxide gas, waste gas that is produced. Okay, another it is nitrogen. You see, air enters the furnace, but we need only oxygen. Okay, so we do not need nitrogen at all. So nitrogen will just leave the furnace, okay, as the waste gas. Alright, so answer carbon dioxide and nitrogen gas. Okay, then, name the zinc compound that is present in zinc blende. Remember, zinc blende it is ZNS, isn't it? And ZNS it is called zinc sulfide. IDE, it has to be IDE. And then you see from gases zinc into molten, you see from gas into liquid, it is called condensation. And then what is the alloy that contains zinc and copper? It is brass. Okay, then you see given with these properties. So, two properties from the list in which copper differs from group 1 elements. See, group 1, what is the differences between group 1 and transition again? Remember, group 1, they are softer, isn't it? Softer, lower density, lower melting point, boiling point. Okay? See, so answer can be, so you see based on here, so what's the properties of copper that is different from group 1, okay? Higher density, higher melting point, boiling point, or it has variable oxidation state. Okay, and then two properties, okay, in which copper is similar to group 1. See, all metals that are good conductors of electricity, metals that form basic oxide, okay, and they are all soluble salts. Okay, then, empirical formula. So remember, see, when it comes into the empirical formula, okay, you have to show the working, okay, because the working carries marks. Okay, so you see, 3 easy steps. Okay, you need percentage, the moles, or ratio. See, percentage given to you here. Okay, and the moles, okay, the formula to be used in the moles calculation here is always N equals to M over MR. Okay, treat the percentage as the mass. So which eventually, so these are the moles that you obtain. And then followed by ratio. So how do you look for the ratio again? Okay, look for the smallest mole, and all the moles you divide by the smallest mole number. See, 1.16 is the smaller, isn't it? So all the moles number you divide by 1.16. So which eventually you get 5, 10, 11. Okay? So therefore, this is the answer. And the empirical formula. Alright, okay, then so as given with the empirical formulas of CH2O with relative molecular mass of 60. So therefore, what is the molecular formula? Okay, so in this case, we need to look for the factors n. You see, m bracket CH2O equals 60. So look for the molecular mass of CH2O. You see, 12 plus 2 plus 16. So eventually get 30. So n equals 60 divided by 30, you get 2. So you know that the factors is 2. So you multiply 2 into the empirical formula, you get C2H4O2. See, if you calculate the molecular mass of C2H4O2, you will get 60. Alright? Then what is the name given to the compound, okay, with same molecular formula but different structures? Okay, it is structural isomers, okay, or isomers, okay, either one will do, okay, as long as you mention the word isomers. Okay, name the homologous series that V is a member of. You see, V is mentioned here. It contains COOH functional group. Okay, so what's the compound again? It is carboxylic acid. Okay, all carboxylic acid that contains COOH functional group. Alright, okay, then draw a structures of T. So this is mentioned here. T is an ester. Okay, T is an ester with molecular formulas of C3H6O2. You see total how many carbon? 3 carbon, isn't it? See, we know that ester is made of alcohol and carboxylic acid. So, so these two are the possible answer. See, total 3 carbon, what? So it can be 1 carbon at the alcohol part, 2 carbon at the acid. Or it can also be 1 carbon at the acid part and 2 carbon at the alcohol part. Okay, so answer it can be methyl ethanoate or ethyl methanoate. Okay, either one will do. See, total is still 3 carbons. Okay, and then V, see, carboxylic acid, okay, with 3 carbon. So carboxylic acid with 3 carbon, it is called propanoic acid. So this is how it looks like. Right, okay, next one. Chemical reaction, you see, step 1. From decayed alkane, you see, alkane to alkane. So what's the reaction called? Cracking. Again, then chemical equations of cracking is mentioned already. This is ethene. Okay, so we know that ethene, it has to be one of the products. Okay, then you balance equation. So another product, it has to be C8H18. Okay, as long as it is a balanced equation. Okay, then from alkene to alcohol, it is called hydration. Okay, C2H4 plus H2O to form ethanol. Yeah, with the chemical formulas of C2H5OH. Alright. Then that's all for this paper. Yeah, hope it is helpful for you guys and hope that you guys love this video. Thanks. Remember to like the video and subscribe to the channel. See you again. Bye.